division. Have you been doing synthetic division also?
Yeah.
Okay, so we can look at those two topics today, among others. Is there anything else you'd like us to look at today?
Well, I have a specific problem here, but I don't know what it's called, but it's graphing polynomials.
Okay, are you able to send that by email or drop it in the chat?
Yeah.
All right, let me put my email in the chat if you don't already have it. However you want to get it to me, and we can start with that.
Okay, let me see if I could email it. Okay, I just sent it to you.
All right, I'll check right now and see what's come through.
I already did like the first 3 on the sheet, but there's like more problems like it that I kind of want to get. Yeah.
And yeah, we can maybe talking through them would help here. Is that a minus 5x plus 3? I can't even. In the question 1.
That's a minus 3x plus 3.
Minus 3x plus 3. Okay. All right. So let me snip that in. You said minus 3x plus 3 like this.
Yeah.
Okay. Great. All right. So let's start with this, and feel free to interrupt me with questions. So one of the things you probably want to do, and you're going to do some factoring. The first type of factoring you might do is a greatest common factor. So on the bottom here, you can factor out minus 3 out of both terms. So you get something like that. And there's a number of steps here. So some books say like, okay, it's a 10-step process or a 7-step process. There's different things you need to identify, which look like they're kind of organized on your paper there. The order kind of matters. We don't have to get super into that right now, but let's talk about domain first. That's actually the best place to start. So the domain is setting the denominator equal to 0. And specifically, it's any term that's got an x in it. You don't have to set the minus 3 equal to 0. It's just x minus 1 equals 0. And that tells you what x cannot be. X cannot be 1. And so this is a problem area. And there's 2 possibilities. It could be a hole. It could be a vertical asymptote. Okay. Do you know which it is in this particular problem?
Would it be a vertical asymptote?
It is. And it's okay if you don't know why. If you don't know why, that's fine. But you find vertical asymptotes generally, VAs, vertical asymptotes generally by, again, setting the denominator equal to 0. So, but it's the factors you want to set equal to 0, not the whole thing. So you'd set x minus 1 equal to 0, x equals 1, and this is the equation of a vertical asymptote. Okay, now what I like to do is I like to graph as you go. I don't wait till the end. I don't know what they tell you in the classroom, but I would not wait till the end to graph it. So a vertical asymptote is a vertical line. It's usually a dashed line like this. Okay, and that gives us some information to start out with. Anything I've said so far unclear? Anything you're not understanding?
Oh, I get it.
Okay.
And I'm assuming for the horizontal asymptote, you'd set the numerator to 0, right?
That would seem reasonable, but you actually don't do that. For the horizontal asymptote, there's actually 3 cases. So case 1, case 2, and case 3. So case 1 is when the degree of the numerator, okay, is less than the degree of the denominator. Now that's very mathy, and I don't expect you to remember that, but maybe you know what the degree is. So the degree refers to the exponent of x. Okay, so in your numerator, do you have an x in the numerator?
No.
No, you do not. So it's really x to the 0. On the bottom, do you have an x?
Yes.
And what is that exponent I just wrote in? Maybe can't
1.
see, just 1. So do you see that the degree of the numerator is 0? is less than the degree of the denominator 1.
Yeah.
So in this case, it is always, there's no exception, it is always y equals 0 is your horizontal asymptote.
Now, what would happen if the numerator was like 2x, for example, instead of just 1?
Yeah, so we'll see that maybe in problem 3. But to answer your question now, that's case 2. And there's kind of a lot that goes into these, but they're very repetitive. So you get, you're going to get it all at one question here. Case 2 is when the degree of the numerator equals the degree of the denominator. Okay. And so in this case, it's the ratio of the coefficients of the leading terms. So let me give you an example that's a little bit more generalized. Let's say it's 3 minus 2x squared over 4x squared plus 1. Okay, which is not your problem, but we'll get back to your problem in a moment. Do you agree that the degree of the numerator is 2? Because of this 2 right here, and it's 2 on the bottom because of that 2 there. It does not matter that the order is disguised here, that they're in different orders. Okay, so the horizontal asymptote is the ratio of the coefficient of the leading terms. So the coefficient of the leading terms in this problem is minus 2 over 4. I just grabbed the coefficients. I don't care about the 3 and the 1. I don't care that it's negative. You just grab whatever it is, and then you reduce. Okay, so that does not apply to your problem, but like if you look down at problem 3, let me snip that in, and we'll just quickly talk about that before we finish up problem 1. So let's say we're asked to find the horizontal asymptote of this thing. The degree of the numerator is 1, the degree of the denominator is 1, and it's the exponent. It's the exponent is what we're looking at. So the horizontal asymptote is the ratio of the leading coefficients, 1 over 1. So it would just be y equals 1. Is that clear?
Yeah, hang on.
If I'm ever going too fast, just tell me to either stop, or you need some time to write everything down, or if you've got.
So by leading coefficients, do you mean the x, or do you mean just the first numbers?
So like that's why I gave you this example here previously. It's the number in front of the leading term. So the leading term is minus 2x squared and 4x squared, but you only care about the coefficient in front of it.
Okay, that makes sense.
Okay, and I was trying to do this to show you that's not necessarily the number in front, because it could be a constant. It could be 3x, it could be other things, which you might see later in this class or in this chapter.
Horizontal. So the horizontal asymptote would be 1.
In which problem? The number 3? Yes.
Yeah.
Yes.
Okay.
Yes. Okay, so we got really kind of sideways with learning stuff, but let's go back to question number 1. The so far what we have found is that there's a vertical asymptote at x equals 1 and y equals 0. You should label those. I'm not big on labeling stuff, but you're supposed to do that. And we talked about the domain. The domain is x cannot be 1. Are you using set notation or interval notation for domain in your class? Do you know?
It's interval notation.
Okay.
So it'd be like negative infinity to 1 in union with 1 to positive infinity.
Exactly. It feels like you have to write a lot to say the same thing, but that's just the way it goes. All right. So now the next thing you look for is an X-intercept. And this is actually, you said this earlier, it's setting the numerator equal to 0. Okay, but the one that we're doing right now is that there's no terms in the numerator. And there's a 1, but there's no x terms. So there is no X-intercept.
Yeah.
Okay, and this isn't a great example for us to start out with, but that's just the way it is. You get the Y-intercept, y-intercept by setting x equal to 0. So this one actually has a y-intercept. Now, sometimes it's better to go back to the non-factored form. Why did I put a negative there? Okay, so it depends on what you're trying to do, what makes the most sense. So you're literally putting 0 in for x. Wherever you see an x, you're going to put a 0 in. Okay, so this ends up being enough tight on space there, but it ends up being about right at 1/3. So when x is 0, y is 1/3. So you put a dot there. Okay.
Yeah, the coordinate would be 0, 1/3, right?
Exactly.
Yeah.
Okay. Now, from here, depending on your comfort level with rationals, you may be able to just draw it. Okay. The next, if you're not sure, there's a couple of options here. One is to test points. So I guess my question to you is, how did you know to draw this when you did this earlier, or whenever you did this?
My math teacher told us that we only actually have to draw on one side, but if you wanted to draw both sides, you'd reflect it.
Okay, that's completely wrong. so okay, let me show you. Oh man, have you seen? There's in one of the Star Wars movies, Luke's like, everything you just said is completely wrong. It's like,
yeah.
Okay, let's try it differently. So let me show you the sort of, it's pretty accurate. It's worked most of the time. At each of these places, I draw little arrows on either side of the graph. Okay, and we have this point right here. So the question is, and it's kind of a game, it's kind of one of those games you'd see if you got on Google Play or Apple Store, where it's like, how can you connect one of these arrows at the top here and go through this point and go to another arrow but not cross the dashed line? Like, here's what you can't do. You can't cross the line. Like, that's not allowed. Okay, but what you can do is you could do something like this. Okay, but then you got the problem of, well, what do I do over here? Well, could it look like this? And maybe the answer is maybe. Okay, so before we answer that, you just need just a tiny bit more information. Do you remember the parent function that this problem is referring to? 1 over x. Have you seen that before?
No, I haven't.
So 1 over x looks like this. It's top right and bottom left. And this is one of those that you're supposed to know, kind of like, a quadratic is U-shaped and an absolute value is V-shaped. So what they do is they do sort of flip and reflect, but it's because it's a parent function of that. Okay, but there's things that can change that. All right. So if we go off this assumption here and we go off the idea that, okay, it's got to go through this point right here, the only way to go through that point is something like this. So we know for sure that that's correct. Okay, and then you see how the parent function is opposite in quadrants?
Yeah.
The same thing has to happen here.
Oh, that makes a lot of sense.
Yeah, and it comes from the parent function. It doesn't just come as some arbitrary, you reflect. Okay, now there are not necessarily exceptions, but the more complicated ones, there are some things that will differ. We'll obviously do a couple more problems like this to see, to get that out of the way here. All right, so if you're okay with it, I'd like to move to question 2. Look at that again. Is that fair?
Yeah, that's good.
Okay. All right, so I'm just going to rewrite this here. It's generally a good idea to put that negative up in the numerator. Okay, and we'll do this in the same order that we did in the previous problem. So you first need to figure out the domain, and you find out the domain by setting the denominator equal to 0. So you set x plus 2 equal to 0, and you find that x cannot be -2. Okay, x cannot be -2 because in math you cannot divide by 0. Dividing by 0 is really bad. So it's everything but -2. And just like in the previous problem, it looks something like this for the domain. Now, the reason you do the domain first is because the domain leads to vertical asymptotes or holes, but we haven't seen a problem with a hole yet, so we'll go to that at some point. So the vertical
Yeah,
asymptotes, go ahead.
my teacher taught us to do the domain last, actually.
Okay.
But yeah, doing it first makes a lot more sense.
Yeah, and you can see why, because it leads to the next thing on the list. Okay.
Yeah.
Which is all right, vertical asymptotes, because you get a vertical asymptote out of the domain a lot of the times. Okay, so the vertical asymptote, you set x plus 2 equal to 0. You get x equals minus 2, not equal to, equals. And that's an equation of a vertical line. Okay. And again, you really want to graph these things as you go. So we'll see if we can do all this in one shot here. Okay, and again, you can draw these little arrows to kind of help out with like, all right, where are we going to connect? What are we going to do? Okay, so the next thing we're going to find is the horizontal asymptote, and you have to look at the degree of the numerator and the degree of the denominator. So the degree of the numerator is 0, and the degree of the denominator is 1, because there's really a 1 above that x. So when the numerator is less than the denominator, it is always, no exceptions, y equals 0. If you take calculus someday, you will learn out why that is. But there's your horizontal asymptote. Again, like I would, until you get super comfortable with these, I would put little arrows to kind of figure out, well, I'm going to connect something. Not sure yet what I'm going to connect. It's kind of like a puzzle. You do the border first, and then you fill in as you go. All right, so now we're going to work on X-intercepts. So here you're going to set the numerator equal to 0 if there's a term equal to 0. If there's an x term, but there is no x term, so there is no, yeah, there's none. You got to be okay with that. All right, there's none. If for y-intercept you set x equal to 0, you can do these in either order. Doesn't really matter. So that becomes -1 over 0 plus 2, which is -1/2. And there's a dot for that on the graph. Okay, so again, the parent function is still this 1 over x. So we know it's going to look, either top right, bottom left, or top left and bottom right. You want to look at that point on the graph and be like, okay, how do I get through that point and connect the arrows but not go across the dashed lines? The dashed lines are kind of like fences. And you can see there's really only one way to do it. You start there and get that in. Can't cross the dashed lines. Okay. And then obviously this one has to be in the other region because the parent function tells you that it alternates like that. To confirm this, that's why I was asking if you've ever tested points. You could actually test a point in the original equation over in this region over here on the left to confirm that it's actually up here. And we may have to do that in future problems.
So to test the point, you'd plug in, like, for example, 0 for x or like +2 for y.
You got to be careful. You got to choose something left of x equals -2. So you might text like x equals -4.
Mm-hmm.
So you would get -1 over -4 plus 2, which is -1 over -2, which is +1/2. And if you were to plot that point, it's actually not the right place, not to scale, right there. It's kind of like now the other point that we did where you have one that it goes through, so you just connect them. But that's the correct way to do it. That's
okay.
That's the full on, no assumptions way to do it. Now, have you ever used Desmos before? Desmos graphing?
Yeah, I have.
Okay. So what I would do, like if I were a student nowadays, I would try and use as much technology as I could. Like I would not be afraid to go to Desmos and graph this one right here. Now I wouldn't graph it first. I know that's like preferred. It's like, all right, let's go graph it and get the answer. I would want to confirm my work with it to help me understand, okay, yeah, I got them right. See where I went wrong. So don't be afraid to use this. I think it's a really good tool. You'll use it more the more math you take. And hopefully you're getting encouraged in class to use that as well.
Yeah, I can also use my graphing calculator, and I do that to check my answers.
Cool. So I've got a virtual calculator, graphing calculator I can work with you on if needed. Okay, so number 3 is a little more interesting because there's more action, more things going on. We're going to start with the domain. We're going to set x plus 1 equal to 0, and we find that x cannot equal -1. So our domain is set. Again, that leads to vertical asymptotes, setting, again, the denominator. You have to know what you set equal to 0 in each case. Vertical asymptotes, again, you set the bottom equal to 0, x equals -1. So we'll start with the graph of that. We're here on the right. X equals -1. So I'll put little arrows, and then we'll connect those at a later time. All right, so what's next after vertical asymptotes?
The horizontal asymptote.
Horizontal, yeah. So we already talked about this one. This is case number 2 because the degree of the numerator 1 is the same as the degree of the denominator 1. It's the exponent, and so it's the ratio of the leading coefficients, which just happen to be 1 over 1 or 1. And you want to draw this as you go. You don't want to wait till the end, especially on a test, because you're already in a stressful situation. You might as well do as much as you can as you go. So thank goodness we finally get a problem where there absolutely is an X-intercept. Are you doing range before I didn't even look?
No, we only do domain.
That's odd. Okay. Like you're leaving out an important thing. All right. So the X-intercept, you're going to set the numerator equal to 0. So x equals 3. So that's the point 3, 0. 3, 0. And then the y-intercept we get by putting 0 in for x. So let's go 0 minus 3 over 0 plus 1 becomes -3 over 1 or -3. Excuse me. So now again, like I haven't done a good job of scaling this thing, but that's not the point here. They're not grading you on how like good of a grapher you are. They're graphing you on the important characteristics of this graph. So obviously it has to go through those 2 points and it can't cross the dashed line. That's why it's there. And this one has the same parent function. Now it may not look like it, but it actually has the same parent function as the others. It's just in a slightly different format. So that tells you, okay, we have to also graph up here, but you can also test a point to find it. So some of the online systems require you to actually graph points, and that's where you'd have to, figure out some numbers over here and see what works. All right. I think so. We've got everything on there. Okay. Do you want to send over some more problems for us to look at, or do you want me to come up with some?
I can just type one in the chat here.
Okay, sounds good.
Oh yeah. Also, he's telling me to solve for the holes too.
There hasn't been a problem yet for holes. We'll address that maybe in the next problem you give me. We'll see.
X equals there we go. So
Okay,
it's x plus 2 divided by 2x plus 8.
yeah, so I'm writing it now. Can you tell me if this is what you meant by what you sent?
Yeah, that's right.
Okay, fantastic. Okay. All right. So if you were to go to your calculator, okay, and this is critical here, is you would want to enter it in this way with parentheses in the numerator and
Mhm.
parentheses in the denominator. And if you ever need me to graph one for you to show you this, I'd be happy to. The calculator doesn't understand unless you tell it exactly what you mean. And you can just do extra parentheses, just be more cautious there. All right, so I mentioned this in one of the earlier problems. You definitely want to factor as much as you can before you start. So do you see how a 2 goes into both terms on the bottom?
Yeah.
So you want to factor a 2 out on the bottom there. That just helps with certain things we're going to do. So why don't you do this? Why don't you calculate the domain for me and let me know what you come up with.
So you set the denominator to 0.
Yes. But you don't have to set, the 2 is not a term with x, only the x terms.
So would it be 8?
You're setting x plus 4 equal to 0.
Oh, so it's 4. Oh
Well,
wait, no.
yeah,
Oh wait, no, it's -4. Sorry.
x
Yeah.
cannot be -4, and then you have
Oh
to
yeah.
write this in interval notation.
So what do you call them? The number in front of the x, that doesn't matter.
No, you only x terms. So a term has to have an x in it for you to do any of this. It's just a distracting number. I mean, it does have meaning, but not at the moment. So notice this.
And
Let's just say you'd set 2x plus 8 equal to 0, and you solved for x. Okay, you're going to subtract 8 from both sides.
mhm.
Then you're going to divide by 2. Do you get the same answer?
Yeah.
Yes, but it's better to factor first. There's going to be advantages later on if you do it this way.
So the domain would be -∞ to -4 in union with -4 to +∞.
Very good.
Yeah.
Okay. Next thing we're going to do are the vertical asymptotes. Now there could be more than one, but not in this problem. How do you find vertical asymptotes?
So you hang on, let me.
Yeah, go back and look in your notes if you're not sure, or if you need me to scroll up, I can do that as well.
So to find the vertical asymptote, so you would set the coefficient, or not the coefficients, sorry.
It's okay. Take a moment to
Oh,
really
you set the denominator to 0, or
right.
the
Right.
yeah.
The domain leads directly to vertical asymptotes.
Yeah.
You set, and again, you could set the whole thing equal to 0, but it's just the x term that you set equal to 0. So x equals, what is
0.
the vertical asymptote? You're solving for x.
4.
How do you undo addition by 4?
Subtract by 4.
You're going to subtract 4 from both sides. That gives you x equals -4. Okay, so we can immediately draw that on here. There's x equals -4.
Is the vertical asymptote always the same as the number you get for the domain?
Yes.
Okay.
Well, for the most part, there could be a hole. I mean, so we'll get to that. Maybe probably get that in another lesson, but we'll get that. Okay, what did we do third? What was our third thing that we found for these graphs?
Horizontal asymptote.
Horizontal asymptote, yeah, okay. Okay, now if we go back and look at the equation, it's x plus 2 over 2x plus 8. What is the degree of the numerator?
1.
1, because of that exponent there. What is the degree of the denominator?
Would it also be 1?
Yes, it's the exponent.
Yeah.
Think of degree as exponent, not coefficient, it's exponent. I know it's a new
Okay.
vocabulary. Now the horizontal asymptote is y equal, and it's the ratio, the division, the ratio of the leading coefficients. So what are the leading coefficients?
1 and 2.
1/2, yeah, 1/2. It could be a fraction, could be a whole number, could be anything. All right, so I didn't do this, but I should have drawn these little arrows. That just helps us to figure out, okay, where is it going to connect? And to figure that out, we next figure out the X-intercept. I want you to look back or tell me how you find the X-intercept. What do you set equal to 0?
You set the x equal to 0, right?
That is for the y-intercept.
Oh,
Let's go back and look at a previous problem here. So for the X-intercept in this problem, we set x minus 3 equal to 0. What is x minus 3? How would you, what is another word to refer to the top?
the numerator.
Numerator. So you always set the numerator equal to 0. So this is like a Quizlet, or back in my day we made 3x5 cards. Somehow you have to commit this to memory, because it's going to come up on a test or a quiz. You're just going to see it. So you're going to have to set x plus 2 equal to 0.
So it'll be x equals -2.
X equals -2. And that's a point on the graph. There it is. Boom, right there. There's a point on our graph. All right. Now, the y-intercept, you mentioned this, you already said this, it's when you set x equal to 0. And so it's easy to confuse the two, and it's easy to plot the wrong points. Just don't do that. Try to find a way to get this down. So you're putting 0 in for x. You're substituting in wherever you see an x. So you substitute in for 0, and you're reducing here. So I get 2 over 8, or 1/4. And like you've told me a couple of times now, these are ordered pairs. So I like to write the ordered pairs, then I graph the point. And then usually this is like where you're like, okay, I got it. Like I see how to connect, the arrow, it's got to go through the points, can't cross the dashed line. So like this is pretty reasonable. And then because of the parent function, we know that it would also be up here. Could also test a point for that. Let me know when you get all this down.
Okay, there we go. I got it.
Okay, so let's try to, so normally my lessons go 50 minutes. I thought this was gonna be a tried out lesson, which is 30. I'm gonna split the difference and do 40 with you today. And then you got another lesson upcoming for another 40 minutes. So what I wanna do in the last little bit of time here is I just wanna summarize what we've been talking about. So let me give you a function here. And let's say it's 5 minus 2x over x plus 1. Okay. And what I'm going to do is we're going to talk about all the things that we've been mentioning. So what did we do first in all of our problems? What did we first find?
The domain.
The domain. So the domain you find by setting equal to 0. So you want to think denominator. Denominator is the domain. But what else do you get? What else do you get out of the denominator? You also get
the vertical asymptote.
Vertical asymptotes. Now, not always, but most of the time. We'll get to some holes next time. Hopefully, we can do another lesson this week to answer some of those questions. Again, you set equal to 0. Okay. The next thing we did in all these problems is we found the horizontal asymptote. Yeah, and so I got to do this slightly differently. Let me go over here and write this horizontal asymptote. So that uses both the numerator and the denominator. Okay, uses both. So you kind of meshing the two, both numerator and denominator. And like if you could only take away like one thing from this lesson today, it's hopefully this last few minutes here that okay, I got to use the numerator and the denominator for horizontal asymptote. There are 3 cases. We only covered 2 of them. You will see the third at some point, but we're not going to deal with that right now. All right, and then what do you use the numerator for? What is the numerator strictly used for?
Let me see.
The X-intercept.
Yeah.
The X-intercept, and you set that equal to 0.
And then for the denominator, it'd be, oh wait, no, sorry. So the y-intercept
yes,
is when you set x equal to 0 on the denominator.
No, and the numerator. So it uses both. Okay, so we can say y-intercept, and you actually already know this from previous courses, but you know, just because it gets jumbled up with all the other stuff going on, the y-intercept comes from both the numerator and the denominator. You set x equal to 0 this time, equal to 0.
Yeah.
All right, so we'll call this lesson 1. You've got another lesson coming. I'm going to give your dad some feedback. I'll basically tell him, easy to work with you. And what I would recommend is putting you on the spot a bit more and giving you a few more opportunities to test your understanding with some questions like this, where you actually have to go through and calculate all these things. But it was a pleasure working with you. I hope you like the format. I hope you found this valuable today. And I will send you the notes and a link to the screen recording here shortly.
Okay, thank you.
Is there any questions I can answer for you at this time?
Oh, that's pretty much it. I just kind of need to memorize them.
Awesome. Yeah, we'll do. I'll recommend your dad we do another lesson some point this week. That way, you know, you can be hitting the rest of your semester strong. All right. Thanks, Jadon. Hope you have a great rest of your day.
You too.
Okay.
Thank you.
Bye now.